Thanks for joining us today to learn about creating event-driven microservices using AWS CDK for .NET. I'm Anita Dinadayalan, and I'm a Developer Specialist Solutions Architect here at AWS. I work for the Developer Acceleration team. In our team, we work with the developer community to help them learn how to build scalable, secure, and reliable systems on AWS. I'm also a full-stack software developer, and I have designed and implemented applications of various architectures: web applications, REST APIs, database programming, UX design, and batch processing, just to name a few. I also have a lot of experience in developing multi-threaded applications and asynchronous processing. Today, I'm going to show you how you can build an event-driven microservices application on AWS using CDK for .NET. In my session today, you will learn about how you can use the AWS Cloud Development Kit, CDK, to create an event-driven microservices architecture. You will learn about some of the important commands that you need when you define the infrastructure using AWS CDK. Finally, I'll show you a demo of how you can create Amazon API Gateway, AWS Lambda, and Amazon DynamoDB using AWS CDK for .NET. With monolithic applications, the services are closely coupled, and it becomes very difficult to modify or add functionality due to the size of the application. Small changes may actually require lengthy regression testing. Businesses around the world are changing rapidly, and rapid innovation is very important for such businesses. Modern application development helps you to bring ideas to market rapidly. In order to make the process agile and more flexible, most organizations redesign the applications into microservices. Each of these services are deployed separately, and all the services work together to offer the same functionality of the monolithic application. Let's imagine that you have split a monolithic application into multiple microservices. Deployments would be much faster if you automate the release process. You know, the tasks of building, running tests, promoting artifacts to staging, and deployment to production. You can also deploy frequently instead of waiting for manual processes. But to get the full benefits of continuous integration and deployment, it is actually important to model your infrastructure as code. By doing it, the infrastructure changes can be integrated into your CI/CD pipeline, and you could provision much faster, and you will be prone to less errors. There are many ways you can create infrastructure on AWS. You can use the AWS console to create manually, or you can use the AWS command line interface. You can also use AWS SAM CLI, which is our Serverless Application Model CLI, for creating the serverless infrastructure. AWS CloudFormation allows you to specify the cloud infrastructure you need in a template file, which could be a JSON or a YAML file, and it provisions the infrastructure for you. AWS CDK allows you to use the programming language you're familiar with to define the infrastructure, and it internally uses AWS CloudFormation to provision the resources. When you use AWS console to create the infrastructure, you can see all the options that are available for creating the service. But this is a manual process, and it is not at all repeatable. What would you do if you have to create a similar EC2 instance in staging and production environments? How do you track the manual changes that could occur within these environments? And of course, it takes much longer to create manually. So this method may not be the best choice for provisioning application infrastructure with many components. Alternatively, you can use AWS CloudFormation templates for defining your infrastructure. You can either define using JSON or YAML formats. CloudFormation is an API wrapper, and it uses a template and translates them into API requests and creates the environment. The APIs are executed in parallel, making the deployment process much faster. CloudFormation also manages the dependencies and relationships for the stacks that get created. This is a small CloudFormation template, and it is in YAML format, and it creates a CloudFront distribution. This can be checked into your source control system along with your application for version control. This can be run through your CI/CD pipeline. You can also easily replicate the environment into other regions. When you use AWS CDK, you can define AWS cloud infrastructure using the programming languages you're familiar with. You can use the tools and skills that you already have. I mean, the programming languages that you already know to define your cloud infrastructure. It's much faster to develop using CDK, and it's also customizable and shareable. You can also build your own components and share it in your organization. CDK is an open source project and it is hosted on GitHub. You can write code in TypeScript, JavaScript, C#, Java, and Python. Here, you see a high-level view of how your CDK application becomes an infrastructure on AWS. First, you will write a CDK application in one of the supported languages to define your infrastructure. In the application, you have to define the infrastructure as stacks. And then from the command prompt, when you execute the CDK commands, a CloudFormation template will be generated from the source file and it gets deployed. The deployment process internally uses AWS CloudFormation to create the environment in the console. Here, you can see how I create the demo stack in C#. I've created an IAM role and a Lambda function. The necessary CDK packages are available on NuGet. When I deploy this code, it will create an IAM role, a Lambda function using the provided zip file, and assign the role to the Lambda function. As you can see, I have written only 10 lines of code to create the resources. Let's now see how using AWS CDK benefits you. Just like how you write your application code, you can now define your infrastructure using conditional logic. You can create a base infrastructure to share among project teams as internal NuGet packages. For accelerated development, you can use the code completion within your IDE. You can use your code review tools and version control your CDK project. Also, you can write all the code in the language that you're familiar with. Before we move into the event-driven application architecture and the demo, you need to understand some basics of using the CDK CLI commands. A stack is a unit of deployment in the CDK application. An application can have multiple stacks, and you can selectively deploy a specific stack by using the stack name. The CDK ls command will list all the stacks in your application. When you run the CDK synth command for an app with multiple stacks, the Cloud Assembly includes a separate template for each stack instance. Even if the two stacks are instances of the same class, the AWS CDK emits them as two individual templates. You can synthesize each template by specifying the stack name in the CDK synth command. I spoke about stacks earlier. A stack is a unit of deployment. Constructs are AWS resources that you can define within the stack. There can be level 1 constructs or level 2 constructs. Level 1 constructs are low level and they directly represent a CloudFormation resource. The next level of constructs, L2, also represent AWS resources but at a higher level. They provide similar functionality but provide the defaults, boilerplate, and glue logic that you would be writing yourself with the level 1 construct. Finally, the AWS construct library includes even higher level constructs, which we call patterns. These constructs are designed to help you complete common tasks in AWS, often involving multiple kinds of resources. The construct Lambda REST API will represent an API gateway backed by the AWS Lambda function. Here, I'm using a level 1 construct to create a bucket. Level 1 constructs have a prefix of CFN in their name. When you use level 1 constructs, you must explicitly configure all resource properties, which requires a complete understanding of the underlying CloudFormation resource model. This is the level 2 construct, and as you can see, I only have to provide the bucket name to create the bucket. For example, the s3.bucket class represents an Amazon S3 bucket with additional properties and methods such as bucket.addLifecycleRule, which adds a lifecycle rule to the bucket. You can install CDK using the npm install command. It has a prerequisite on Node.js, and you have to make sure that it is available on your machine. These are some of the commands that you would use to create and run a CDK project. You have to initialize the app using the CDK init command by specifying the template and the required language. CDK synth synthesizes and prints the CloudFormation template on your terminal. CDK deploy will deploy the stack, and CDK destroy will remove the created resources. In your root directory of the CDK application, you will be able to see the cdk.json file. CDK synth runs the .NET run command to generate the CloudFormation template. Please note, all the CDK commands should be run from the folder where the cdk.json file resides. So, this is the architecture of the application that we are going to create today. There are two microservices here, place order service and update inventory service. When the client sends a request to the API gateway, the place order service gets called, which triggers the update inventory service. The update inventory service will decrement the stock in the DynamoDB database. This is a serverless microservices application architecture. I'll be showing you how this can be created using AWS CDK using C#.NET. In our demo today, I'll show you some of the CLI commands that you will require for creating the infrastructure with CDK. Then I'll show you how to create the microservices architecture that we just discussed using CDK for .NET. Then I'll show you how this newly created environment looks like on the AWS console. I'll start with showing the CDK version. I've already installed CDK on my machine, so I'm going to check the CDK version now. So if you see, I have 1.104 installed. I've created a demo application using a CDK init command. I have created 2 stacks in it. I'm going to show you the stacks in the demo application by using a CDK ls command. Okay, there is a demo stack and an S3 stack that you will be able to see now. I'm creating the event-driven microservices architecture in the demo stack and an S3 bucket in the S3 stack. Next, I will run a CDK synth command. So when I run a CDK synth command, the CLI will create the CloudFormation templates and store them in the cdk.out folder. If you see, the output has been written to the cdk.out folder. Next, I will go into the folder and show you the template file for the S3 stack. This template will have the CloudFormation templates for creating the S3 bucket. So I'll do a VI of the template file. That is the CloudFormation template that has been generated by the CDK synth command. Next, I'm going to show you the cdk.json file. So I'll go back to the demo folder. If you see here, there is a command to run the .NET project. That is a language-specific content in the cdk.json file. So I will show you the demo folder contents. See, if you see here, you have the source, lambdas, the cdk.out folder, and the cdk.json. Next, we will be looking at the CDK code for generating the infrastructure. I have created 2 stacks, demo stack and S3 stacks. This is the S3 stack, and here I'm actually creating a bucket and I have enabled versioning on it. So the S3 stack class, if you notice, it was derived from the base class stack, and that is a single CloudFormation stack. Okay, so in the demo stack, I'm creating an IAM role, Lambda functions, API gateway, and DynamoDB table. For the IAM role, I create using the role class, and I have added the manage policies that are required by the Lambda functions. You can either add the manage policies by name or by using the ARN. So I've created, like, some I've created using name and one of them I've created using the ARN. Next, I'll be creating the Lambda function. So I've initialized the runtime, the handler, the timeout values, the code and the role, all the configuration I've done here. So similarly, I've also created the place order Lambda function. For the API gateway, I'm creating a REST API, so I use the REST API class. I've added the resource as orders at the root of the REST API. It's slightly below. And I've also configured the various parameters to create the environment. Like the pass-through behavior, the integration responses, all those parameters that are required for configuring the REST API, I've actually configured it from code here. So after this, I'm creating the DynamoDB table by the name of inventory, and it has a partition key of item ID. And I have granted full access to this table for the update inventory Lambda function. Now I have code for creating the infrastructure. Then I'll show you how you can create it, how you can deploy it to the console. So I'll be doing a CDK diff command now. So when you do a CDK diff, it actually shows you what infrastructure that gets deployed to the console. Now I'll run a CDK deploy. So when I run a CDK deploy, this infrastructure, it will be created in the console. It's asking for confirmation, so I do an yes. So it has started to deploy, and it's creating the demo stack now. It's going to take a few minutes to complete. It's now completed, so let us now see the created resources on the console. So I'll go into the S3 console. If you see here, the bucket has been created, and I'll show you the versioning. So if you go into properties, so see, you can see that the versioning has been enabled. This particular thing I configured from the CDK code. Let me go into IAM next. I want to show you the role that we created. So click on roles, and I'll search for order. Here it is. So I click on it, then you can see all the policies that have been attached. Whatever I wrote in the code, so they've been attached here. Next, I'll go into the Lambda functions console. Okay, there you go. You can see the place order Lambda function and the update inventory Lambda function. In the update inventory function, it has actually been created with all the provided parameters. So it has the handler information. I'll go into the configuration to show you the timeout value that I created. So if you go to general configuration, there you go, it has the 5 minutes value. Next, I'll go into the DynamoDB console to show you the inventory table. So I go to tables, see the inventory table has been created with a partition key of item ID and the read and write capacity units. So they've been configured to whatever I've set in the code. And that is the item view. If we create any items in the table, it will be shown here. Next, let's look at the API. There's the order servers endpoint that I created. You click on it. The orders resource has been created. And if you look at it, the Lambda function has been correctly linked and all the other parameters have been updated. So when you go to stages and production, this is also something that I created from the CDK code. From here, you can get the invoke URL. The code, the API has been deployed, and you can get the invoke URL from here. And this brings us to the end of the demo. You've now seen how you can create event-driven microservices architecture using CDK for .NET. There are multiple digital and classroom trainings that are available for you to learn AWS and build your cloud skills. Please check aws.amazon.com/training for more information. Apart from digital and classroom trainings, you can also look into the certifications. Lot of resources are available online. Please let us know what you thought about today's event by completing the survey. This will help us improve the event experience for you in the future. We hope you enjoyed the session. Thanks for being here, and we look forward to seeing you the next time.